In this lesson, we're going to focus on one particular exponent, the power of 2. Now this shows up quite a lot in math, because we often do want to just multiply a number by itself. And the power of 2 is a convenient way of representing this. So much so that we have a particular name for this power, and we also have a particular interest in its inverse, which is another thing we're going to focus on today. Suppose we have a square which is 6 units wide and 6 units long. Now we can form this square out of smaller unit squares. And because our square is going to be 6 units wide and 6 units long, we have 6 times 6 squares, which is 36. Now let's generalize this to any size square. If we want to make a square whose sides are n units long, we need n times n, or n to the power of 2, unit squares. In fact, this relationship between the power of 2 and a square is why multiplying a number by itself, or applying an exponent of 2, is actually called squaring. So if we're going to answer the question, how many unit squares form a square with sides 6 units long, the answer is 6 squared, which we can also write as 6 times 6, or 36. Now the inverse, or the opposite, operation of squaring is the square root, which is represented by the radical symbol. The number underneath a radical is called the radicand. The square root of n is the number whose square is equal to n. So a square root represents the answer to the opposite question of what we asked before. So if we ask, what is the side length of a square made from 36 unit squares, the answer to that is the square root of 36, which equals 6. Now a number which results from squaring a whole number is called a perfect square. In fact, we can find the first 20 perfect squares by squaring the numbers 1 through 20. The square root of a perfect square is always a whole number, but the square root of any other number will be between whole numbers. In fact, these square roots can only be approximated when using finite decimal places. So as an example, let's find the square root of 289. Well, this is 17, because 17 squared, which is 17 times 17, is equal to 289. Suppose we want to find the square root of a number which is not a perfect square, such as the square root of 52. Well, 7 squared is 49, and 8 squared is 64. So this tells us that our square root is going to fall in between 7 and 8. We can probably expect the square root of 52 to be closer to 7 than 8, because 52 is not that much bigger than 49. Now if we want a more accurate estimation, rather than just somewhere between 7 and 8, we should probably use a calculator. The square root of 52 is approximately 7.211. Make sure you know how to enter square roots on your calculator, because every model of calculator may represent them slightly differently.